Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesday. This time, we are going to be talking about a specific provider, the AWS provider, and a specific set of resources inside that provider. Yes, we're going to be talking about Aws Kms. So I hope that has piqued your interest. If you've ever struggled with KMS, hopefully, this is almost going to be an explainer about KMS a little bit, in addition to also how you can consume it using Terraform. So we're going to get into both of those things. Before we do any of that, I do want to talk to you for a second about this whole Patreon thing that I'm doing. So I have a Patreon, and because everybody does, right? And that's a requirement. And it starts at only $2 a month, which is, that's not a lot. It's like tiny little bit. Now, what do you get? What do you get with that? Okay, fair question. Well, for starters, you get a weekly newsletter from me about what I'm doing and my top 5 cloud posts of the week, what I found interesting that you might enjoy reading. So you get that newsletter. That's kind of nice. You also get early access to these Terraform Tuesday videos. So I make these available a week earlier on the Patreon. And also you get, access to me, sort of, and anybody else who's on the Patreon. So you can start up a chat or whatever. And I might drop some other interesting tidbits in there as well. So that starts at $2. If you bump up to the next level, then you get your name in the video. So that's also cool. But no, okay, enough about that. I'm not going to push it any further. If you're looking for it, links down in the description, or you just search Ned in the Cloud on Patreon. Let's get into the topic at hand. This topic came from a viewer who left a comment asking if I would cover AWS and KMS. And I was like, can I make a whole video out of that? Of course I can make a whole video out of that, because KMS is confusing. Now, I mostly deal with Azure, so I'm very familiar with Key Vault. You may already know that. And I also am very familiar with HashiCorp Vault. In fact, I've done courses on Pluralsight on both of those things. I am less familiar with KMS. I have consumed it through the AWS managed flavor, but I haven't really used it extensively, aside from a project a long time ago where I had to actually use Cloud HSM, which at the time was like $5,000 a month per HSM instance. That thing was expensive. Okay, so it's been a little while. Had to do a quick refresher, and I thought, hey, why don't I make this part of that refresher? Why don't I tell you a little bit about what AWS KMS is? So KMS stands for Key Management System. What kind of keys are we storing in the system? What are we managing? We're managing encryption keys, or I should say cryptographic keys is what we're managing here, to be more specific. And those keys can either be symmetric or asymmetric in nature. But I'm getting ahead of myself. Why don't we go over to a little presentation I prepared, and we can take a look at what actually goes into managing those keys. All right, like I said, let's start with some basics here, right? When you're managing the keys, you're managing either symmetric or asymmetric keys. So that's the first distinction to make. The algorithm by which it creates those key pairs, don't worry about it too much. You can get that's a whole rabbit hole that you can go down to with elliptic curve versus RSA versus AES. The only thing you really need to know at this point is there's symmetric and asymmetric. Symmetric keys means you use the same key to encrypt your data and also decrypt your data. So it's actually a lot faster to do from a computational perspective, but it is considered somewhat less secure, because if anybody gets hold of the key, they can decrypt anything you've encrypted. Okay, so that's symmetric keys. There's also asymmetric keys, which those are actually a key pair. And asymmetric keys are used for a lot of things. Your certificate on a website would be an instance of a public key or public certificate, whereas the private side is the private certificate. So what can you do with public-private key pairs? Basically, anything you encrypt or sign with the private key can be decrypted or verified with the private key, and vice versa. Anything you encrypt with the public key can only be decrypted with the private key. So that means you can send someone your public key. That's why it's called public. And they can verify that things that you send them are encrypted and signed using your key, because only you can encrypt it with the private key. You keep that private, and then if they decrypt the data and verify the signature, they know it came from you. And also they can encrypt things using your public key, and only you can decrypt it now because you have the private key. So that's the whole idea behind public-private key pairs. Computationally, it's more difficult to decrypt and encrypt data, but it's also considered somewhat more secure. And because you can also just verify things with a signature, that means you can sign and verify stuff in addition to encryption and decryption, which is why there's more actions associated with it. Okay, so that's a little primer on encryption keys and how it's implemented with KMS. All right, now let's take a look at a little more information about KMS, because when you generate a key, whether it's symmetric or asymmetric in nature, you need some sort of key material to form that. If you've ever used OpenSSL to generate keys, there was a time where you had to move around your mouse to generate random data as the seed for the key. Similar situation here. When you're generating those keys, the material needs to come from somewhere. It can come either from AWS itself. It will provide the material and manage that material for you to generate that key. And in that case, the resource type that you're using in Terraform is AWS_KMS_key. That's the resource type if you're using AWS sourced material. If you want to bring your own material to the party, it is now the AWS KMS external key, and it's external because you are managing the material. Now, there's a bunch of implications on when you choose to use external. You're now responsible for more things. AWS can't automatically rotate the keys, some other stuff. Again, if you really want to get deep into it, you can go and read the documentation for the KMS, but that's why there's two different key types for the resource. It's because one uses external material that you bring, and the other one is internal material that's managed by AWS. Okay, so that's key material. Now, your key is going to have a key ID, a globally unique key ID. That's not very useful when you want to refer to the key. So you can also create what's called an alias. And the alias simply refers to a specific key, but you can reassign that alias to a different key as long as the key is of the same type. I don't know if it has to be the same exact encryption algorithm, but you can't assign an alias that's currently on a symmetric key to an asymmetric key and vice versa. I've definitely run into that roadblock. So the alias is just like a user-friendly way to refer to it, and also you can refer to it in your programming or something else, and then you can change the underlying key later without having to update the alias value. That's the whole idea. So if you are referring to a key alias in your programming or in your script, you can do it by alias and know that you can always retrieve the current key that alias is associated with. So that's the whole point behind the alias. The last thing I want to mention is security. And boy, howdy, AWS really likes making security complicated. If you've ever dealt with S3 bucket policies and IAM policies and how they all interact together, guess what? You're in for a treat. Keys are the same thing. So at a high level, every key has to have a key policy associated with it, and that defines permissions that are specific to just that key. You can also assign permissions using IAM policies, and those IAM policies can refer to either an individual key or a set of keys in an account. Okay, so you can do that. There's also what's called a attribute-based access control. So this is an RBAC, it's ABAC, and that allows you to control permissions to the key based off of tags and metadata values, basically. So you can control access that, and I believe those go into the key policy. And then lastly, you can give temporary permissions to a key through a grant, and that grant can be cross-account and is meant to be very temporary, and you can scope it to specific operations. So there's a lot of ways to control permission. The main thing you have to understand here is that grants are another Terraform resource type because you can create a grant on a key. Okay, so hopefully that sort of covers the grand scheme of things when it comes to AWS KMS. Now, why don't we get into an actual demonstration of how you would use the AWS provider and the resources and data sources for KMS to interact with AWS KMS. So let's jump over to Visual Studio Code and do that now. All right, let's get into it. We are in the directory 2021-04-13, and that date is because that's when it gets released to patrons. So hey, if you want to become a patron, you'd get access to this on the 13th and not the 20th. But if you're patient, that's cool too. Don't worry about that. So that's the directory. If you're looking for these files, you can always find them on my GitHub. There's no paywall or anything behind that. You just, go find me on GitHub. The link will pop up, around now. And I also included a README in this directory that goes over some of the things I already talked about, and also it gets deeper into some of the resources and data sources that are associated with KMS. So we already talked about the key and the external key, and I talked about the alias. But one thing I didn't talk about was we have all these different access control mechanisms. Where do you actually set that stuff? And so if you're doing key policy, you define that directly in the KMS key resource. If you want to do it with IAM policy, well, there's a separate resource just for creating IAM policies. For the attribute-based access control, that is set in the AWS KMS key resource. And then finally, grants have their own dedicated resource. So that's where you set all that stuff. Again, it's not very clear in the Terraform documentation, so I thought I would make it more clear here. There's two other things I wanted to mention. One is a pair of resource and data source called Aws Kms Ciphertext, which allows you to send plain text and have it encrypted using one of the keys in KMS, and Aws Kms Secrets, which allows you to decrypt data that was encrypted using a key. And one of the things I discovered when trying to consume this is that it has to be a symmetric key. It won't let you do the private key, public key encryption and decryption. It has to be symmetric key for whatever reason. That's the way the resource and data source are designed. Let's get into an actual example here. We're going to start with EBS. And what we're going to do is just encrypt an EBS volume. Not going to attach it to an EC2 instance or anything like that. Now, when it comes to KMS, you generally don't consume it by itself. It's usually in service of some other service within AWS. In fact, many services in AWS are using KMS for their encryption under the covers using an Amazon managed key. For instance, S3, the contents of your bucket are encrypted, but they're encrypted using a key that's completely managed by AWS. It's only when you want to use your own customer managed key, or CMK, that you would actually need to interact with the KMS service directly. So let's take a look at let's say you wanted to encrypt your EBS volumes using a CMK, a customer managed key. How would that go? Let's go ahead and expand out the EBS directory. We'll open up the main.tf. Don't worry about what's at the top. It's just invoking the provider and whatnot. The things that I want to point out is, first, we're creating a resource called AWS KMS key, and we're calling it EBS for our internal referral. And the only thing in there is description equals EBS key. And that's because there are a bunch of defaults that are used by this resource type. So if you don't put anything in here, it's going to assume that you want to A, use symmetric keys, B, that you're going to be using this key for encrypt and decrypt, and C, that you want this key enabled by default. And you'll notice there's no key policy in here, even though there needs to be one. Amazon is automatically going to generate a key policy for you if you don't specify one. So if all you need is a KMS key, that's it. You don't even need the description. That's optional too. I threw it in there just so it would seem like something was going on. And then if I want to use it in the EBS volume attributes, or arguments, I should say, I set encrypted equals true. And then the KMS key ID, I have to set that argument to the ARN of the key I just created. That's it. So if we go into that directory, and we'll go ahead and we'll just do a Terraform apply, and we'll do auto approve because I don't feel like waiting. I've already logged in through AWS, so this is is using a pre-existing login for the provider, so I don't have to do that. And this should go really quick, right? Creating the key takes no time at all. The thing that actually takes time is creating the EBS volume. Boom, there we go. I didn't pause or anything. That's just how quickly it does it. So now we have an EBS volume that's encrypted using that key. And that's it. It's very, very simple. Now, what if I wanted to use a key for my S3 bucket, let's say? Let's go ahead and expand out the S3 folder, and we'll take a look at that main.tf. And for this one, let's say that I want to use an existing key. So this is a key that I've already provisioned. And I actually have a little script here. If you want to create a key to do this, bash or PowerShell 2 commands, one will create the key, and then the second one will create an alias using that key. So let's say that we have a key already existing. We want to use it for our S3 bucket. How do we do that in Terraform? The way we're going to do that is by using the Aws Kms key data source. So we're going to use an existing key, and we can look up the key ID by the actual key ID. If you already have that, well, you actually don't really need the data source unless you need some other property of the key. You could, a lot of times you can just supply the key ID. But let's say you needed the ARN, which we need in this case. We're going to look it up by alias. So the only thing we need under the key ID argument is the name of the alias. All aliases start with alias / and then the name of the key, or the name of the alias that refers to that key. And then in our bucket, we're going to create a bucket, and under server-side encryption configuration, we have to put a rule in there that says we're going to encrypt by default. Here's my KMS master key ID pointed at our data source that we just created, and the algorithm we're going to use, which is the KMS algorithm for server-side encryption. So this, again, relatively simple. We're just using a data source to use an existing key. If I go up, go into my S3, and we'll just run Terraform apply auto approve, and hopefully I didn't delete that SS key from when I was testing this. I think I left it in place because I knew I was going to reuse it. There we go. That's it. So the bucket already existed. All it had to do was go grab the ARN of that existing key based on the alias and then use it for the bucket creation. Now that bucket exists. I'm going to delete it later, so don't worry about it. You may want to, if you're going to run through this yourself, change the bucket name to something unique for you, just so there's no collisions, but I'm going to delete mine, so it probably won't exist. All right, so that's another way to use it. Let's look at one more way to use it, and in this case, we're going with the Cipher Text. So let's take a look at what's in this file. All right, let's scroll down a little bit, and the first thing we're going to do is create a key, and this time I'm actually going to put a little more information in here. Now, I don't actually need to put most of this information here. Again, it uses the defaults. But for key usage, I'm going to say encrypt, decrypt. The other one is sign and verify, I think. For customer master key spec, this is where you tell it what algorithm to use. So I'm using symmetric default, which I think uses AES in the background. So I'm using that. But you could specify like RSA underscore 4096 or the elliptical curve ones, which I can't remember off the top of my head because they're confusing. You can specify that different. But then you have to make sure that the key usage that you want is available for that customer master key spec. For instance, elliptical curve, I believe, can only be used for signing and verifying and not for encrypt, decrypt. So just like make sure that the algorithm you're using actually matches up to what you want to use it for. I've also enabled key rotation, which is only available for symmetric keys and not asymmetric keys. All right, so we're creating ourselves a key. And now we're going to associate an alias with that key. So I'm using the Aws Kms alias resource, and I'm giving it a name of alias cipher key. And then I'm in the target key ID, I'm just pointing it at the key ID of the key I just created. So now I have a key and an alias. If I want to change that alias at some point later, I can just specify a different target key and it'll change. All right, now let's do something with that ciphertext. And I've got a few different resources in here. I've got one called Aws Kms Ciphertext. What this resource does is it takes plain text as input, and you have to tell it what key you want to use for the encryption, and it will hand you back a ciphertext blob that has that encrypted text in it. So we're going to do that, and then I'm going to use a data source called Aws Kms Secrets. What does that do? Well, that allows you to decrypt any number of secrets. You can have one or more secrets blocks inside this data source. And all you have to tell it within the secret block is give the secret a name. How do I refer to this when I'm working with this data source? So I'm going to call my secret recipe. And then The payload refers to the ciphertext blob that was used. And you notice I'm not letting it know what encryption key I used to do this. And the reason I can do this is because within that ciphertext blob is the context of which key was used to do the original encryption. So as long as I have access to that key, I can decrypt that ciphertext blob. If you're using a different algorithm, I believe you have to specify both the algorithm and the context for it. But because the context is embedded in the way that we encrypted the data, we don't need to do that. If we scroll down a little bit more, I'm going to use a different data source. This one is an Aws Kms Ciphertext data source. And you're like, wait a minute, isn't that the same name of something you just used? Yes, same name of the resource up here. It's now a data source. How is that different? Well, what's interesting is for the resource, because it's a resource and it has information in state, the ciphertext blob stays the same after each apply. With the data source, because that's not stored in state, it computes a different ciphertext blob each time you run and apply. So depending on which one you want, you would choose either a resource or a data source for doing that ciphertext. And then I have a number of outputs to just kind of show what's going on with all these different resources and data sources we're using. So let's go over to that directory. And I called that what? Ciphertext. All right. And we'll do a Terraform apply auto approve, and we'll see what output we get from that. So it's going to create my KMS key. That should go relatively quickly. All right, apply complete. So under the data ciphertext, let's just take a look at what we got for output. We've got data ciphertext. So this took this string up here and encrypted it using the key that I specified. And if we just look at the ending, we'll compare that later when we run this again. It spit out the key ID. It also, here's the resource ciphertext. So this is the ciphertext that it created using the plain text that is up here, using this plain text. And then I submitted that ciphertext blob right here to the Aws Kms Secrets data source, and it decrypted it for me and returned the plain text value. So I can get that data back out. And if we run this process a second time, just give it a second to recompute. There we go. All right, so if we look at our data ciphertext, this one ends in FC5NNW. And our previous one ended in this ZFPK. So we can see that the data ciphertext is different when we ran apply again. Now, our resource ciphertext ends in 01XBK. If we scroll down, look at that. It's 01XBK. So every time you run apply, the resource is going to compute the same ciphertext because it's actually just reading it out of state, whereas the data ciphertext is going to be updated on each apply. So just bear that in mind. I don't know exactly what use cases that would be, but that is a pretty significant difference in the way the two function. And again, we were able to decrypt data that had been encrypted with a key, and all we would need is access to that key and make sure that the context associated with that ciphertext blob is something that AWS can ingest. Now, like I said before, I had to do this with a symmetric key because the way that the Terraform resource is written only allows you to do it with a symmetric key. If you're using the AWS CLI, you can actually do it with either asymmetric or symmetric. It's just in this particular case, the way the Terraform resource is written, and I guess the data source, it has to be a symmetric key. If you wanted to do the decryption yourself, just to see how it works from the AWS CLI, I have some instructions in the steps.sh, so you could also follow that along. And that's why I spit out the key ID along with the cipher blob, so you can actually go through it at the AWS CLI if you wanted to. All right, so that was quite the adventure that we went down on AWS KMS and using Terraform to manage it. One of the big takeaways for this, well, I think just being cognizant of how AWS KMS works and some of the intricacies there is going to be really important if you want to use it for a Terraform resource. And I feel like that's true of almost all of Terraform. Terraform is not going to tell you how to use things. It just allows you to use them in a consistent way across different clouds. That's like kind of the whole point, right? They're assuming you know how to work with KMS. They're just trying to make it easier to consume using infrastructure as code. So you need to understand the context of how you're going to use KMS, and then there's a number of different resources and data sources that allow you to use it. I think one of the more useful ones is being able to look up the key by alias, grab the ARN, and then use it with whatever other service you wanted to. And a lot of time, like I said, KMS is actually kind of used in the background by a lot of the other AWS services using Amazon managed keys. So a lot of the time you're using KMS and you don't even need to know about it. So that's also an option as well. Hopefully you found this interesting. Just remember, I'm always looking for new ideas for Terraform Tuesday. So if there's something you're curious about, you want me to dig in a little bit, give it this kind of treatment, leave a comment, reach out to me on Twitter. It's Ned1313, or hey, become a patron and you can drop a comment there. Lots of options for you. If you don't want to become a patron, I totally get it. Times are tight sometimes. It's only $2 a month, but it is $2 a month. So if that's not your thing and you want to subscribe to the channel, I really and sincerely appreciate that. If you want to like this video, I appreciate that as well. Please don't hit the bell. You don't have to like that. No one wants that. No one wants constant notifications on their phone. There's a new video, so you don't have to do that. And share with a friend. Just let someone know that this is going on. That'll do it for me today. Until next time. Stay healthy, stay safe out there. Bye for now.